Welcome back, Legacy students. This is Miss Marsh speaking. Today we're going to look at section 2.6, which is on ratios, rates, conversions. Today we're going to focus on just ratios and rates. Please make sure, of course, as always, that you have your notebook, because you're going to want to take notes again, writing utensil, and today you are going to want a calculator, because you're going to need it to see where I'm getting some of these numbers. So, what are we going to focus on today? Today we're going to look at how to find ratios and rates. Specifically, we're going to look at what a unit rate is. First, some vocabulary. You're going to want to make sure that these get down in your notebook. So, write these down. So, a ratio compares two numbers by division. So, these are going to look like a rational number. So, a ratio can also be written in three different forms. One of them looks like a rational numbers. One of them has a colon in between, or you can just write the word 2 in between. So you can say this is, you can all read them though as A to B for all of these. Now, a rate is a ratio that compares two quantities measured in different units. This could be like $25 for 2 shirts. So I could write that as a ratio of 25 over 2. So that would be a ratio. A unit rate, though, is a rate with a denominator of 1. So we're always going to divide those two numbers. And we're going to take a look at an example of that later. So here's the first example. We need to find the following ratios. So I notice I have squares, and I have some circles here, and I have a few stars. So they want us to find stars to squares. So I'm going to count how many stars I got. I have 1, 2, 3, 4, 5. So I got 5 stars. So I'm going to go 5, because that's the first thing that they're asking, to squares. So I need to count how many squares. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 squares. So I have 5 to 11. Alright, now they want to know about squares to circles. So I already know that I have 11 squares. And I need to find out how many circles I got. So I have 1, 2, 2 circles. So I'm going to write that off to the side here so I can keep these in mind. So I have 11 squares to 2 circles. Alright, so they want about stars to circles. So I have 5 stars, so I'm going to write 5 here. And then they want to know about 2 circles. So 5 to 2 circles. Now they want to know circles to stars. So I'm going to look over here. I have 2 circles, and I have 5 stars. Notice how these are reciprocals of one another, because the words are. So stars to circles, I need to go stars over circles. And circles to stars, I gotta go circles over stars. So these are 2 different kinds of ratios. Now they want stars to all figures. So I know that there's 5 stars. And they want to know how to all figures. So all figures means every single one of these figures added up. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, it looks like. So, I have 18 figures in all. Now they want to know about squares to all figures. So I have 11 squares, and I have 18 figures. Notice how none of these fractions simplify down into lowest terms. Let's take a look at the next problem. They want to know there are 30 students in a class, including 16 boys. Rate each ratio. There should not be an N there. Each ratio. So, girls to boys. We don't know how many girls there are, but we do know that there's 30 students and 16 boys. So, if I go 30 minus 16, I get that there are 14 girls in this class. So I got 14 girls to 16 boys. Now, I notice these two numbers can be simplified, and I always got to simplify ratios. So I'm going to divide both of these by 2. Because both of them have a 2 that can go in. So 14 divided by 2 is going to give me 7. 16 divided by 2 is going to give me 8. And that is as simple as it can be. Now I need boys to girls. So I have 16 boys and 14 girls. Again, I notice I can divide a 2 into both of these. So I'm going to get 8 over 7. Now they want about girls to all students. So I have 14 girls again. And they want all students. And I know that there are 30 students in this class. Now I look and I notice that both of these can be divided by 2. So I'm going to do that. 14 divided by 2 gives me 7. And 30 divided by 2 gives me 15. Boys to all students. Now boys, I know there's 16 boys to 30 students. So I need to simplify this. So I'm going to divide both of these by 2. And I'm going to get 16 divided by 2, 8. 30 divided by 2, 15. So those are the two ratio problems we're going to look at. Now, this is more about rates. So I'm going shopping for t-shirts. And I want to know which store has the best deal. Which one's going to make me pay less money for one shirt. So I'm going to write these as rates. So I know I can have $25 for 2 shirts. So I'm going to write these as ratios. Over here, I can have $45 for 4 shirts. In store C, I have to pay $30 for 3 shirts. Now, to compare these, I need to get a unit rate. To find a unit rate, you're going to divide the numbers. So I'm going to do 25 divided by 2. And I get, if you do it on your calculator, you will get $12.50 for 1 shirt at store A. Store B, now we're going to do 45 divided by 4. And we're going to get that we're going to pay $11.25 for 1 shirt. And for store C, 30 divided by 3 is $10 for 1 shirt. So I'm going to look here. Which one would I rather buy? Do I rather buy $12.50 per shirt, $11.25 per shirt, or $10 per shirt? Being that I'm looking for the best deal, I'm going to want to shop at store C because they are the cheapest amount per shirt. Last problem. So Trisha ran 10 kilometers in 2.5 hours. Jason ran 7.5 kilometers in 2 hours. And then Olga ran 9.5 kilometers in 2.25 hours. So who had the fastest average speed? So I'm going to write here. I got Trisha. I have Jason. And I have Olga. So Trisha can run 10 kilometers in 2.5 hours. Jason can run 7.5 kilometers in 2 hours. And Olga ran 9.5 kilometers in 2.25 hours. So what we're going to do is we're going to divide again. So we're going to go 10 divided by 2.5, and we get that that is 4 kilometers per hour. Jason now, 7.5 divided by 2 will give me 3.75. You can try that on your calculator if you want. So he's running 3.75 kilometers per hour. So he's running a little slower than Trisha. Now about Olga, 9.5 divided by 2.25. Divide that, you get 4.2 repeating. So I'm going to put the bar over the 2. Kilometers per hour. So if I look here, who has the fastest? They want the fastest average speed. So she's running 4 kilometers. Jason's running 3.75, so Trisha's faster. Then Olga is running 4.2 kilometers, which is faster than Trisha. So Olga is running fastest. I hope you enjoyed the video. See you next time.